Good afternoon. I'd like to welcome the panel members. Good afternoon. I'd like to welcome the panel members in the audience to the November meeting of the Scientific Guidance Panel for Biomonitoring California, more formally known as the California Environmental Contaminant Biomonitoring Program. Thank you all for joining us today. I am Kim Gettmann, OEHHA's Deputy Director for Scientific Programs. The panel last met on August 27, 2025. The August meeting included updates on Biomonitoring California program activities, including a presentation on the Biosphere study results. The panel also heard from 2 guest speakers on the use of silicone wristbands to assess personal chemical exposures, followed by a discussion on the use of the silicone wristbands to complement biomonitoring studies.
Sorry, Kim, can you talk a little bit more into the mic? It's hard to hear.
Is this better?
Yes.
Okay, thank you. Key discussion topics included potential source of elevated inorganic arsenic in participants of the California Regional Exposure Study in Los Angeles, or CARE LA, analytical considerations when biomonitoring for microplastics, the utility of microsampling devices to collect blood for biomonitoring studies, the evaluation of results, return materials that study participants receive. The panel also discussed results from the Biosphere study, including the higher levels of 2-naphthyl, a metabolite of naphthalene, in Biosphere participants compared to the levels in the NHANES. In the afternoon, the panel discussed the possibility of using silicone wristbands to complement biomonitoring studies with guest speakers and program staff. Key discussion topics on the wristbands included the utility of wristbands as passive air samplers compared to other methods of passive air monitoring, best practices, ideal study design, and quality assurance, quality control procedures necessary to ensure accuracy of measurements of chemicals on wristbands. Chemicals or chemical groups that are appropriate or not appropriate to measure using silicone wristbands, and variables that might influence chemical concentrations on the wristbands. Ideal populations the program should consider for use of silicone wristbands in biomonitoring studies, and participants' perspectives on receiving wristband results. The summary and transcript of the meeting is posted on the August meeting page of the program's website at biomonitoring.ca.gov. I'd like to announce Amy Padula will be our acting SCP chair for this meeting. I will now invite panel members to introduce themselves by name and affiliation. Let's start with Jenny Contenta, who is attending remotely. Jenny has been granted a reasonable accommodations to attend this meeting remotely and maintain with her camera off.
Hi, everybody. I'm Penelope, or nicknamed Jenny Quintana, from the San Diego State University School of Public Health, Division of Environmental Health.
Thank you. I will now call on panel members Laura Cushing and Luda from UC Irvine, who will also be attending remotely.
Hi, I'm Laura Cushing, Associate Professor of Environmental Health Sciences at UCLA.
Hello, I'm Ulrika Luderer. I'm Professor of Environmental and Occupational Health at UC Irvine.
Thank you. And now I will start at the end with Tom.
And sorry, this is Stephanie Jarmel, just to make an announcement that there are very few microphones. I apologize. So we'll need to pass them around and make sure you talk directly into them when you're speaking. Thank you.
I'm Tom McCone, Professor Emeritus of Environmental Health Sciences at the University of California, Berkeley School of Public Health.
Jose.
Jose Suarez is Associate Professor in the Herbert Wernheim School of Public Health and in the Department of Pediatrics at UC San Diego.
Oliver.
Oliver Fien, UC Davis. I'm a professor in the Genome Center.
Amy.
Amy Padula, Associate Professor in the Department of Obstetrics, Gynecology, and Reproductive Sciences at the University of California, San Francisco.
Tamar.
Hi, I'm Tamer Durrani. I'm Professor of Medicine at UCSF in the Division of Occupational, Environmental, and Climate Medicine.
And Carl.
Carl Craner, or my distinguished professor emeritus at UC Riverside in philosophy, and distinguished professor, and not distinguished professor, faculty member of environmental toxicology at University of California, Riverside.
Now I'll hand off the meeting to acting panel chair Amy Padula, who will provide more details about today's meeting. Thanks so much, Kim. So as a reminder for panel members, please comply as usually with the Bagley-Keene open meeting requirements that all discussions and deliberations of the panel about subject matters at issue today need to be conducted during the meeting, not on breaks or with individual members of the panel on or offline, including via phone, email, text, or chats. And panel members who are attending remotely must visibly appear on camera, with the exception of Jenny, during the open portion of the meeting. And if you are unable to keep your camera on during the meeting because it's technologically impractical, please make an announcement when you turn your camera off. And additionally, if someone older than 18 is in the room with panelists who are attending remotely, you must disclose the presence of that person in their general relationship to you. So just want to confirm with our panelists that are online. Laura, Ulrike, and Jenny. As for an overview of the meeting, so we will hear an update on program activities, including a presentation on persistent organic pollutant levels in Californians. The second portion of the meeting will include a joint presentation of collaborators on results and impacts of the farm worker women and respiratory exposure to smoke from swamp cooler air, the Fresca Mujeres study. And finally, we will hear about and have an opportunity to provide input on plans for the scientific guidance panel meetings in 2026. And there will be time for questions from the panel and audience after each presentation. And if SGP members wish to speak or ask a question, please raise your hand and I'll call on you. Or Jenny, you can speak up since I'm not sure if I'll see your hand, but and then you can ask your question or provide comment. If online webinar attendees have questions or comments during the question period after each talk, you can submit them via the Q&A feature of Zoom or by email to biomonitoring@oehha.ca.gov. We will not be using the chat function during this meeting, and please keep your comments brief and focused on the items under discussion. Relevant comments will be read aloud and paraphrased when necessary. If online attendees wish to speak during the public comment periods and discussion sessions, please use the raise hand feature in the Zoom webinar, and Rebecca Beloso will call on you at the appropriate time. Please make sure that you join the webinar under the name you would like to be identified as when commenting, including if you would like to remain anonymous. If you are attending in person and wish to comment during the public comment periods and discussion sessions, please come to the front or raise your hand and I will call on you at the appropriate time. For the benefit of the transcriber, we encourage you to clearly identify yourself before providing comment and write your name and affiliation on the sign-in sheet at the back of the room. However, there's no obligation to identify yourself and you are free to comment anonymously if you wish. At the end of the meeting, there will be time for open public comment period. And I think now we will begin the first presentation. So Nerissa Wu will be providing the first presentation, and she leads the exposure assessment section in the environmental health investigations branch at the California Department of Public Health and the program lead for Biomonitoring California. And she will provide an update on the current program activities.
All right. Thank you, Amy, and welcome everybody to our last scientific guidance panel meeting of the year. As usual, I will be giving the program update covering the usual things that I talk about: surveillance, community-focused studies, laboratory work, and our outreach and communications activities. As you remember, we have a number of surveillance studies in the works. We have CARE, the California Regional Exposure Study, STEPS, the Studying Trends in Exposure in Prenatal Samples, and MAMAs, measuring analytes in maternal archived samples. I will actually only be touching on CARE and STEPS because we have a more detailed presentation on MAMAs from the presenter after me. So news from the CARE study, Toki Filman's work, in which she has presented on associations between PFAS in drinking water and serum PFAS levels. She's presented it here, and it's been a topic of discussion. This work has just been published in the Journal of Exposure Science and Environmental Epidemiology. It's open access, and there's also a link available on our website if you are looking for that publication. So in addition to that paper, we also have a 2-page fact sheet, which gives a high-level summary of the paper, and it's currently in our review chain, but we expect to have that released publicly soon. Also from the CARE study, we talked about our last meeting about new data on speciated arsenic and phenols for CARE LA. We've been meeting with different researchers to discuss potential directions and approaches to research into that, into exposure sources. We did also say that we're going to post the summary statistics for speciated arsenic and phenols. We haven't yet done so because we noted a small calculation error on the slides. And so we'll be correcting that. We'll be posting the summary statistics, and we'll also issue a new set of slides. The storyline doesn't change. It's a very small numerical change, but we just want to make sure we have the most accurate numbers on our public website. So we also have new laboratory results. Speciated arsenic for CARE 2 study participants has just been received by EHIB. So we'll be conducting results return and summary statistics for those. And then of course that data can be folded in with the CARE LA data, giving us more power to do statistical analyses. We're also working on the phenols analyses for the CARE 2 participants, and we expect to have those next year. In STEPS, this is a study that uses banked prenatal screening samples from the genetic disease screening program to determine population estimates of PFAS exposures over time. In Orange County, I think last time we talked about this, there were a number of samples that had to be rerun for QA issues. That's been completed, data is in review, and it's projected that we'll have the data finalized and reported to us in early December. The lab is continuing to make progress with the Fresno County samples. We're around 75% of the lab run. And we can't really talk a lot about the STEPS data yet because it's still being finalized, but we're really excited to see the data because it's going to help us understand not only the temporal trends, but also help us understand what PFASs we need to keep our eyes on. And in related news, this is not STEPS, but related to the issue of identifying the universe of PFASs of concern, we have sent samples from the intra-program pilot study, the IPP, to Amira Salamova's lab for measurement of ultra-short chain PFASs, and we're expecting that data to be reported to us in early 2026 as well. So turning to community-focused studies, I will be providing updates on these 3 community studies: ACE, the Asian Pacific Islander Community Exposures Project; Biomosphere, the biomonitoring component of the San Joaquin Valley Pollution and Health Environmental Research Study; and I'll be introducing CHAIRS, the Community Health and Air Quality Implications of Refinery Retirements in Los Angeles. For ACE, you've heard Kelly Chen talk about her work looking at the associations between seafood consumption and PFAS serum levels. This has been submitted to the Journal Exposure and Health, and we just heard on Monday that that manuscript has been accepted, so we expect that to be coming out in publication quite soon. And our outreach and communication folks have been working on different ways to get this really important message out to broad audiences. So as I mentioned for Toki's paper, there will be a 2-page summary of findings that will be distributed, as well as a postcard that's in lay language, very simple message that will go out to all study participants, but we'll also be distributing it at community events and to our community partners to pass along to their constituents. There's also a suite of social media postings on PFAS generally, but more specifically about seafood and drinking water. And this approach to publication also applies to another paper we have coming out that I don't have a slide on because it's such recent news. I want to mention that Kathleen Atfield's paper on flame retardant levels following household furniture replacement has also been accepted for publication and will be out in early December. And similar to ACE, we have a suite of communications materials coming out on that. So I should really acknowledge our biomonitoring outreach and communications group, which has been super, super productive and active and responsive to all of these findings and publications we have going out. In Biosphere, the focus has been on results return evaluation, which we talked a little bit about last time. We've been working with UC Merced and the Central California Asthma Coalition to assess our results return materials. We returned Biosphere results over the summer, and then CCAC reached out to recruit participants to be part of one-on-one interviews about their experience with our results return materials. They then asked those interview participants to be part of a focus group to discuss both the existing paper materials that they had seen, but then also to look at the same type of materials but presented through the Silent Spring Derby platform. They have just finished running 3 focus groups, 2 in Spanish, 1 in English, each with 5 to 8 participants. So we don't have transcribed notes from that. We've just gotten some anecdotal findings from them. But you know, the challenges we face that are inherent to biomonitoring, of course, are present in this evaluation as well. Our biomonitoring message is complex and it's hard to boil down to short, simple sentences, and results are not really a one-size-fits-all situation. We do hear from participants who want all the science, they want all the details, but we also are hearing from many participants that they really need a much more apparent, readily accessible message back to them about the results. So again, illustrating it's really important for us to continue to do these evaluations and particularly to include a diverse group of participants so that we are aware of and hearing about the challenges that they face when they see our materials. I'm going to briefly introduce the CHAIR study, Community Health and Air Quality Implications of Refinery Retirements in Los Angeles. This is a collaboration with UCLA, with Laura, UC Irvine, and with Yale University. So the goal of this study is to assess the retirement of 2 petroleum refineries in Los Angeles, if it's associated with changes in exposure to air pollutants and various markers of health. So the study will include fresh air wristbands. We're a little bit different than the silicone wristbands we talked about last time. There will be stationary monitors and collection of health indicators, including blood pressure, lung function, and airway inflammation. So the role of Biomonitoring California is to look at biomarkers of exposure. There will be up to 150 residents of the surrounding communities, including Carson and Wilmington. Participants will provide 4 urine samples in total, 2 while the refineries are active. So study enrollment and sample collection is already underway. And then the refineries are scheduled to be shut down at the end of the year. And then 2 more samples will be collected in fall 2026. Right now, we're planning to have EHL analyze the urine samples for metals, along with specific gravity and creatinine for dilution correction, and then aliquots will be stored for potential analyses of VOCs and PAHs. That's just a very quick overview. There will be subsequent meetings where we talk more about the details of that study. And then just briefly, I've already mentioned our lab activities in conjunction with our projects. EHL is working to provide CARE2 data. We just got our speciated arsenic, which is awesome. And phenols analyses are underway for the remaining 194 participants of CARE2. And ECL is focused on analyzing the STEP samples. They still have Fresno and then the Los Angeles samples, and then we will be getting more samples from the 2024 birth. They've also just completed proficiency testing for persistent organic pollutants, including PCBs, PBDEs, and organic chlorine pesticides. And then in addition to conducting analyses for existing studies, both labs are preparing to participate in the next round of the intra-program pilot study, which is designed to evaluate the use of microsamplers for PFASs and metals. So I give this program update a few times a year, and it often feels like I'm not doing a great job of conveying all the different activities that are going on and how much multitasking is going on among our staff. And this graph does not really, I'm not sure it helps. It's a schematic of all the steps that a study might involve. But I think it's more helpful actually to look at it this way. And I have this animation, which I apologize, it's not really helping illustrate my point here. me show it to you this way. I just wanted to convey all the various studies and the types of program activities that are taking place right now. We are involved with sample collection for chairs and for IPP8, looking at microsamplers. Our labs are involved with analyzing step samples, as well as CARE 2, and they are preparing to receive samples from chairs and IPP8. Our statisticians are working on results return and summary stats for the prior round of IPP, looking at PAHs, as well as speciated arsenic for CARE 2. And they're doing further statistical analysis related to CARE, MAMAs, SAPEP, Biosphere, and Fresca Mujeres. And there are multiple panels involved with each of those, which each involve literature search and consideration of what the exposure sources might be. And then, of course, as I mentioned, for all the publications or findings that come out of that work, our communications group is working on fact sheets and other public-facing materials related to all of these studies. And then in addition, there are many activities that are related to moving the science of biomonitoring forward that's not necessarily attached to a particular project. So we have development of laboratory methods, evaluation and standardization of statistical methods, creation of templates for communication materials across the board, review of scientific literature, and assessment of field methods. And all of this is, again, moving the science of biomonitoring forward so that we can incorporate it into future biomonitoring studies. And none of it gets done without this awesome group of people. And that is what I have for you today.
So we can take questions from the panel to start, and this is just an opportunity for clarifying questions. There'll be a discussion later.
Very interesting. I have some questions about the refinery studies. So there's 2 refineries that are shutting down. You're going to do some samples now while they're still operating, and then after they're closed, right? Is there an opportunity? So I assume the closure will involve remediation, and a lot of refineries have a lot of contaminated materials on the site that actually slowly outgas some of the things. Is there a way then to go back even a couple of years later when they've fully remediated the sites and eliminated some of the like smoldering residues?
Good point. Well, I actually will call on Lara or Stephanie to answer that.
Great question, Tom. Well, we are planning on going back next fall to collect additional samples, and depending on funding, we're hoping to add a 3rd year onto the study to come back the following year again to see if any of the levels have changed.
So you're there. One more.
Okay.
So refineries have continuous emissions, but they're also notorious for flares, which are off normal, and in theory, they don't get permits for flares because it's a safety, they have to burn gases. But my understanding, there's actually some significant emissions that come out of flares. But if you're doing a urine sample, it's just a snapshot. Is there any, again, has anyone given thought to like a biomarker that would reflect a longer term cumulative exposure? I don't know what that would be. Like the magic exposome.
I mean, maybe if we were able to collect blood, but that is not the current plan for the study. Metals that we're measuring, they can have a lot longer half-lives, might be indicative of longer term exposures. But for the pHs and VOCs, what we're measuring, that is more like a cross-sectional point in time. Yeah, but I know there was a recent flare-up in one of the refineries in LA, I think a few months ago. So hopefully there's no more, and hopefully we don't capture it if there is one, but yeah.
Thank you. A very interesting study.
Any other questions? I actually have one. That's okay. I wanted to know, I imagine this will get discussed maybe more at another time, but the fresh air bands, I'm just wondering how they differ from the silicon in terms of what they are measuring or how long they're measuring it.
So and Laura, correct me if I'm wrong, but the fresh air wristbands are different in that it's more like a passive air sampler. So they're not actually, cutting and testing the silicone itself. Yes, it's technically a silicone wristband, but there's actually a little mini sampling device on it, which is more catered to capture air exposures, particularly instead of air and dermal that the wristband would.
Thank you. Oh, thank you.
You can just stay up here.
I know.
Jenny,
Go ahead, please, Jenny.
Hi, I just had a clarifying question about the CHAIR-LA study. What were the inclusion or exclusion criteria for the participants?
Laura, do you want to take that one? More specifics?
Sure. They had to be adults, 18 and over. Just because we didn't have the resources to do justice to a children's study. We were pretty limited in resources, so we decided to focus on adults. They have to live within a couple of kilometers of the refinery property boundary. They have to have lived in the neighborhood for at least a year and have no plans to move in the next year. And they cannot be tobacco smokers. And that was primarily because that would probably really drive the personal exposure measures if we were to include tobacco smokers. And they had to speak English, Spanish, or Tagalog.
So they couldn't be smokers or live with smokers?
They could live with smokers.
They could live with smokers?
Yeah, but they couldn't be,
But you would have that information captured, right?
yeah.
Okay, because that might affect things. And also, I was just curious if you either ask about this or had a requirement that they not commute a long way or spend a certain amount of time at home, or was that just something you capture with questionnaires in terms of their commuting behavior or on-road exposures?
We captured in the questionnaire, it's not an exclusion criteria. Part of the, I think just mostly for practicality reasons, logistical reasons. So we will have some commuters in the population for sure.
And this is Stephanie. For the urine samples, at least, we'll be collecting the first morning voids, at least, which should be more indicative of their at-home exposures.
Thank you.
great. Thank you so much, Nerissa. Oh, are there any other questions? Okay. Okay, so in the next agenda item, we will be hearing from Ian Tang. Ian Tang is a research scientist in the Environmental Health Investigations Branch at CDPH, and he will give a presentation on persistent organic pollutants, or POPs, levels in Californians.
Thank you for the introduction. I'm Ian, and today I'll be talking about persistent organic pollutant levels in many of the studies from Biomonitoring California. And specifically, we're trying to get to the question of how we asked, shouldn't hexachlorobenzene be decreasing in Californians? And a version of this presentation was given at the Joint International Societies of Exposure Science and Environmental Epidemiology. And that was in Atlanta earlier this year. So just to recap, persistent organic pollutants are persistent due to their strong halogenated bonds with carbon. They bioaccumulate due to their lipophilic properties, and they are also toxic to multiple organ systems. They include organochlorine pesticides, such as the ones listed here, beta HCH, DDT, DDE, HCB, or hexachlorobenzene, transnonachlor, oxychloridane, and also polychlorinated biphenyls. So widespread use of POPs occurred from the 1940s to the 1970s. HCB was introduced in 1945. And around 1970, in the 1970s, restrictions began for POPs, and HCB was regulated in the United States in 1984. By 2004, POPs were regulated by the Stockholm Convention, and in 2006, Biomonitoring California began and also started conducting studies. So last year, you all heard that participants in MAMAS 1 had HCP levels around 6 to 8 nanograms per gram, but subsequent MAMAs in 2015 and 2016 showed that there was an increase to about above 10 nanograms per grams per lipid. And there was also 100% detection frequency for HCP. So we looked at all the other POPs and found that overall they're decreasing with each subsequent MAMAs. And so this led us to do some investigations on HCP, which is one of the most persistent of the persistent organic pollutants, and the half-life is about 6 to 11 years, depending on the media. It's also used as a fungicide primarily, but it can also be a byproduct of other chlorinated solvents such as PCE and TCE. So given that POPs have been restricted for almost 20 years around the world and over 40 years in the United States, I think that we would expect to see a decline in POPs over time. The fact that we don't see this with MAMAs led us to try and look at this trend across all Biomonitoring California studies. And so the hypothesis that we were looking at is, are POPs actually decreasing? So we combined all of our student studies together into one data set and restricted it to women of reproductive age, just to match what we had in MAMAs. The total N was 649 women, and a third was Hispanic, and the mean age was 30 years old. So here's a table of all of the studies that we've conducted where we have POPs data, and luckily they've been all analyzed by DTSC, so it's all the same lab. And these studies span from 2010 to 2017, and there's some overlap between some studies. So this subset includes mothers, firefighters, Kaiser Permanente members, and also prenatal screening participants across different regions of California. We analyzed all of the different OCPs I mentioned earlier, and we also looked at PCB 153, since it's one of the most abundant PCB congeners. To look at the time trends, we use linear regression with the sample year of collection used to predict the log transform analyte concentration, and we adjusted for age and race ethnicity. POPs were lipid normalized. We also set the level of detection to be standardized across all the studies to the highest one, and beta coefficients were back transformed to percent change, and we also looked at Spearman correlation coefficients to examine possible monotonic trends. So here are the geometric means by year, excluding PBDE, just because the magnitude is large. You can see that ACB here in gold appears to be increasing with time, while all of these other POPs are decreasing or have low concentrations. And just to show DDE, it's also sort of decreasing by time. And here are the adjusted percent changes of POP concentration by year. I also have the geometric means listed over there. PBDDE has the highest geometric mean of 39.9 nanograms per gram lipid, and HCB has the second highest at 10.5, while all the other POPs are around 2 to 3 nanograms per gram. The adjusted percent change I've highlighted in green indicates a decreasing percent change, and as you can see, all of these POPs are decreasing by year except for hexachlorobenzene. We had crude estimates, and they were not very different from these adjusted estimates. So there are several limitations to this analysis. We used different populations from different geographic regions, and we're really not able to differentiate the effect of study from year. And also, we had a low number of individuals in some years. We conducted several sensitivity analyses. We looked at the trends among men and women of all ages. We also excluded individuals with high LODs, and we also used a meta regression to control for study heterogeneity. We found that these estimates were generally similar to this primary analysis. And in the future, we hope to add one more study, which would hopefully double our sample size and also adjust for more confounders such as breastfeeding, pregnancy, and nativity. So what's going on? Our studies sort of indicate a geometric mean about 10 nanograms per gram lipid. We compared this to NHANES and found that HCB levels, depending on the population, sort of varies around 6 to 12 nanograms per gram. And this table shows the weighted arithmetic mean for NHANES Hispanic females. A subsequent study looking at NHANES cycles from 2005 to 2015 cycles found at least square geometric mean range of 8.9 to 9.6 nanograms per gram lipid. And they only found a negative 1.6% change for HCB across all of these cycles, whereas the other POPs had a percent change of about 8. And just going through this, other populations such as in Belgium, Atlanta, a control set for an ALS case control study found that the median or geometric mean was about 7 to 13 nanograms per gram lipid. So the next question is, what are the possible exposures that could be leading to HCB plateauing in humans? HCB has been detected in some of the foods, but the residues tend to be very low. There's a possibility that HCB in the ocean or in the soil is being disrupted and revolatilizing into the atmosphere, leading to readmissions. There's no known hazardous waste incinerator or industry that produces HCB in California, but we can't rule out that there are industrial sources from other parts of the world that could be transported through long-range transport. Lastly, HCB can be a byproduct of the other chlorinated solvents. And also there's been a lot of historical use, such as it was used as a wood preservative, rubber, aluminum, magnesium, and also dye. So the literature on HCB in the environment is also compelling. A lot of studies have shown that it's either staying stable or increasing. One of them is shown here, where there were air monitors in the North American Great Lakes. And you can see HCB in the bottom right-hand corner seems to be stable, while all the other persistent organic pollutants are decreasing over time. And this timeline was from 1990 to 2015. Another study looked at air monitors comparing HCB levels from 2016 and 2006. And so the circles on the maps represent that ratio of 2016 over 2006. And over 68% of these sampling sites had a ratio above 1.2. And that large black circle on the map indicates it's in the country of Latvia, and there have been studies in the Baltic Sea also showing that HCB trends were either stable or increasing. So we have a lot of questions, more so than we have answers. Are HCB concentrations plateauing? Is this because of a new or existing exposures? Are these a level of concern? And this really shows that HCB can still, because it's a persistent organic pollutant, can still be affecting our society, even though it's been regulated for so long. And even if it's being emitted somewhere, it could still end up everywhere. And it also shows how important our surveillance of POPs are given the restrictions. And if anyone has any clues on how to identify possible sources, that would be great. And so I'd like to acknowledge all our collaborators, funding sources, and our participants over the years.
Any questions?
Yes.
Questions from the panel?
Yeah, that's fascinating or scary, but it's certainly interesting. Now, I understand that your study was focused on females because of the mamas, the samples that you had. But what about other people? Have other people also looked in men? Mm-hmm. There must be other, literature mm-hmm. Where people try to look at historic trends.
There are a few out there, and they've also included men, and there's also been a few studies on children as well. And it appears that the trend is similar in terms of HCB being staying stable. We've talked to some of our NHANES colleagues, and they also see the same trends about both men and women.
Yeah, and a follow-up. I mean, hexachlorobenzene is, of course, well all the carbons are satisfied with chlorine. Is that a physical chemical reason why maybe it's just much more stable?
It is quite stable. I'm not sure if I can answer any more about that. Does anyone have any thoughts?
Okay.
Okay, yeah.
It's very stable, but it's also very lipophilic. And there are other compounds that have shown this kind of long-term behavior, the dioxin-like compounds. And you cited Ron Heitz. He had actually some really interesting papers about retention of dioxin type compounds in all kinds of lipid membranes. And I suspect this might be doing the same thing. What happens is it's very lipophilic, it's very persistent. It goes into anything that's lipid and then slowly outgasses as it goes into the atmosphere and then it maintains a constant concentration in the atmosphere, and then the atmosphere feeds the food chain.
Right.
I suggest if you want some insight, you might want to talk to Matt McLeod at Stockholm University. He actually gave us a presentation. When did Matt talk to us?
2 years ago.
I mean, anyway, he knows OEHHA, but he's done a lot of work on persistent pollutants and global transport and re-emission cycles, and how like lipid and soil feeds food chains on a continuing basis.
Right.
So you might want to just see if he has some insight about this. He's probably, there are others, but I think he's one of the best people out there doing this kind of work.
Thank you so much. We'll reach out.
And I just want to open it up to discussion for both of the presentations, both Nerissa's and Ian. Oh, and sorry, go ahead first, Laura.
Thanks. Yeah, you mentioned wanting to control for nativity in some of the additional analysis you'd like to do. And I was just curious, do you know what the proportion of immigrants is in your pooled sample and how it might have changed over time? I'm not sure if that could be a factor, but I know, the year when HCV was banned in different countries, differed. So,
Right.
I was just wondering if you had taken a look at the distribution of immigrants over time in the pooled sample.
Yeah, that's an excellent question. I don't know what the distribution on the top of my head is. We're still in the process of harmonizing all of this data in terms of across all the studies. However, some of these studies are, for instance, in some of the best studies are in the Central Valley, and a lot of those individuals are immigrants. And so I think it's a little bit different for each study, but yeah, we'll definitely take a look at the distribution and try to understand it a little bit better.
Okay, go ahead, Jenny.
Hi, thank you. And I did have the same question as Laura, and either country of origin or where they were born, because I think also their mother's body burden might affect the children. But specifically, I'm wondering, did you have data on BMI or obesity levels? I know that I would try to look at the literature on obesity and POPs, and it's confusing. It's not a straightforward story, to me at least. I was trying to wade through it. And I guess a related question for the panel looking forward, I'm kind of curious how Ozempic or those kind of drugs might affect our biomonitoring. I know that rapid weight loss, does tend to flood the body with some of the stored pollutants. And so just looking forward, maybe that would be something to look at as well. So that's a bunch of questions in one. Thank you.
That is a really interesting point about Ozempic and how that might sort of remobilize POPs. Maybe it's something we can capture in surveys, but yeah, in terms of your previous question on BMI, some of our studies, we do have BMI. However, because the most recent studies that we have is based on mamas and they are coming from the biobank, their prenatal screening samples, we don't necessarily have good data on everyone for that. So it is something that we're considering. Maybe we can run a sensitivity analysis subsetting it among individuals where we do have BMI. But yes, excellent point. Thank you.
Oh, go ahead. And please introduce yourself if you could.
Martha Sandy, OEHHA. I wonder, Ian, if you could go back and show us, you had a slide on your sensitivity analyses and pulling in all men and women, and then maybe one of the slides looking at other POPs and just read for us what they were, because to get to Dr. McCone's point of, and the question about what's special about hexachlorobenzene, some of the other POPs I think are also fully chlorinated or brominated, or we could think about PCBs and PBDEs and things like that. Could you go back?
Sorry, so it was the sensitivity analyses and then maybe this slide.
I think you had some nice graphs, time trends too, but the
I see.
sensitivity analysis with the all the different groups you tried, because you were looking at women of childbearing age and then you looked more broadly.
Right.
To go over that again, just to pull that up.
I see. Okay, so I have the results of those if that's in.
Or just to remind us what you did.
Sure. Yeah. For the sensitivity analyses, we combined both men and women across all of our different studies together. We also, because in the analysis showed here, we also restricted to women of reproductive age. We expanded it out to all women, and also because the mamas had different, they had higher LODs because they were using Bank serums. The LOD is a little bit higher, and so if we were to sort of model it, it would change the shape of the regression. So we wanted to restrict and standardize the LODs across all of the different the different studies, and also see what happens if we just excluded the woman who had the highest LODs, to see if that was biasing the results or the trend that we're seeing. With meta regression, we also looked at it, the geometric mean by studies. And so this is a way to control for the study heterogeneity that we have. So it's expanding, it's coming from the individual level back out to the population level. And so the magnitudes are much more different. They're much larger and a little bit more unstable, but I think that that's something we would expect to see when we're able to account for this study variability. Yeah, does that answer your question? Yeah, okay. Yes, hi.
Jose Suarez, UC San Diego. Thank you for the presentation. I just had a couple of questions about your methodology for calculating the percent change.
Mm-hmm.
If I can dive in a little bit deeper with that.
Yeah, so we calculated the beta, and this was using the log transformed concentrations, and so we back calculated it using exponentiation of the beta -1 times 100.
I guess my question is, so if you wouldn't mind showing us let me see the slide. I think slide number 8 is the one that lets us take a look at things a little bit, right? So we're looking at the trends there, excluding DDE because the magnitudes are way higher. That's the next chart. Overall, from your analyses, you're showing that they were decreasing except for hexachlorobenzene, right? If we're looking at the figure here, though, however, it's kind of hard to look at that. But it's very hard to look. But oxychloroquine and PPDDT, which are the 2 lines in the bottom, they actually seem to be increasing over time once you look very carefully at that. And part of where I'm going to with this is, so you're calculating the percent change from 2010 through 2016, right? That's the percent change.
Yeah.
And so part of the concern here too is that in 2010 there are only 34 participants that had a measurement, right? So how much you can generalize or how stable you think those concentrations are are probably lower than once you start going towards 2015, 2016, where you reach 236 and 206, right? And the other part of worth taking a look at too is when you're calculating percent change, especially with variables that are highly skewed, right? So these, I presume that are pre-skewed as they tend to be, right? Then when they're in the very low concentrations, even tiny changes can result in very substantial percent change. So you must have had to, at some point, restrict outliers to be able to come up with numbers that are not, 300% decreases, 500% decreases. So in other words, I would suggest also looking at the absolute difference by the time period. And then something worth considering, is it worth it to compare back to a sample with only 34 observations in it? Or can you start maybe grouping them and say, well, the 2020 and the 2012 one, you group all of those as your baseline category. And from there, you can start doing the comparisons and maybe you can start getting a little more stability there with your estimates.
Right, yeah. I think that's a great point on the starting value being n equals 34. We are trying to get an additional study around the same time, specifically the California teacher study, which will increase our sample size up, I think, by 1,000. So that hopefully should address some of the concerns there. But I do take your point. I think the idea of combining the like earlier studies together to gain a little bit more numbers is a good idea. And yeah, it's an interesting point trying to think of what the percent change would represent, because I think we were thinking that the slight increase over time that we see could be because of the level of detection differences. But yeah, we'll look into it some more. Yeah, thank you. This is a lot of feedback.
And technically, they should coincide, right? So even with these, it's hard to see it in this figure. I had to like really zoom in quite close to see that there's slight increases in those two, right? Yeah. So I think just some methodological adjustments there, I think might be good. Okay. Look at the absolute as well. Yeah. To see if that starts matching up a little bit closer to this.
Okay. Yeah. Thank you so much.
Any additional questions? I just have one additional follow-up question. It sounds like the upcoming sub-analyses by parity and things will be, of course, interesting. I was also wondering, since some of those women were, some of the cohorts were pregnant and some of them were not, have you lumped the pregnant and non-pregnant ones yet? Or I mean, I know most of them are mamas, but there's one other.
Yeah. We've lumped them all together in this case. Yeah. For example, in a woman of reproductive age who were not pregnant would be included with the pregnant. Yes. Yeah.
It's fascinating, and I have a kind of a follow-up question on that, which is breastfeeding. Do you happen to have information about breastfeeding duration or breastfeeding or not, given that there's a good amount of data showing that a lot of these pops can be excreted by breast milk?
Exactly, yes. So that is data that we have collected and we've harmonized. However, they're not available for everyone in mamas, and also some of the clinical data for some of our cohorts, we don't have that data. So if we were to actually do this analysis adjusting for more confounders, then we would expect the sample size to decrease just because of the data availability.
Yeah, I'd be very curious. I wonder how many of these studies. I mean, it's not a huge sample size. Yeah. But if there's, I'll just be personally very interested in seeing duration of breastfeeding, how that correlates.
Definitely. Yeah. Yeah. We have some of that data, so it's very exciting. We're so I think we're waiting for the CTS data to come in and then see how we can reanalyze the data. There are at ISCE, ISCS, there was also a couple of folks who wanted to collaborate and maybe add in more cohorts. We've been also considering that as well, just to see if we can just gain more power and more people in each year. But we're still thinking about how to do that, since there's like different labs and different techniques and different populations and stuff.
Can I ask the SGP question?
Hi. My name is Dean DeBrock. I'm a research scientist with the California Department of Public Health. I was wondering, there was one PCB used in this analysis as like the expected to be most detected, persistent PCB, but to get to the point that was brought up previously about how chlorinated HCB is, are there any other PCBs or dioxin-like compounds that one would like to see if we could get that data?
Is the question going towards the, well, I think the
Sorry,
underlying
can you
part here.
identify yourself for the transcript?
Oh, sure, Jose Suarez. So part of this too is HCV has a substantially longer half-life than the other ones. Than most of, not that all of it. It's not the one that has the longest, probably the ones you measured, the longest, but among the longest half-lives, right? So I wonder if do you think your question goes in that direction? Are there other more persistent pesticides or, excuse me, chemicals that should be measured that were very prevalent at some point, and maybe we should be monitoring that a little bit better?
Yeah, I'm basically asking the SGP for their recommendation of if we have the data or could get the data, what would they recommend?
And follow Tom McCone. I have to be careful. It isn't just persistent. And this is where it helps to talk to somebody who does fate modeling or fate analysis, because it isn't just the half-life, it is the vapor pressure, the solubility, and the water solubility, air solubility, vapor pressure, and how these play together and where the reaction takes place. So if something degrades in water, but is really not soluble, it's not in water, it's how much gets into. So again, you can't really understand this because you've got about at least 6 different parameters that you have to put together. And that's why I say that people like Matt McLeod who do this know how to take this. And they actually, he's run all these chemicals through their, how to rank them in terms of their overall persistence, based not just on their persistence in one medium, but in the total environment. And that relates to how they make their way around the environment. Like some things go into sediment and get buried, and other things go into sediment and just sit there and slowly go into the water column as the concentration in the water column goes down, and then go into the atmosphere and then get circulated. So some get buried, some get circulated. You don't know that without really running it through these sorts of fate analyses. And then you can start seeing how these substances all compare to each other. And again, it's already been done. You know, I think you just call somebody who's been involved in persistent pollutants for 10, 15 years, and they'll say, oh yeah, here's the paper. We ranked them all in terms of their global persistence and their likelihood to end up in the food chain and their likelihood to end up in human lipids.
Any further questions?
Just a reminder that they can ask questions on the program update as well,
Right.
in case there are any. Nerissa's very happy I said that.
Hi, Tamer Grani. This is, I guess, for both of you. I've heard 3 different labs now. It sounds like environmental health lab, environmental chemistry, and DTSC. And Nerissa, it sounded like part of the support role is to come up with a lab's development and so forth. So can you talk a little bit about how that goes about and how you choose which lab and which analytes go where and that kind of thing?
Sure. There are 2 labs as part of the biomonitoring program, and one is the environmental health lab at CDPH, and they generally measure metals, and then the urinary non-persistent chemicals like pHs and VOCs, and then our persistent organic pollutants and PFASs are measured by the environmental chemistry lab that's over at DTSC. Now, one of the pressures on the program is there are all these emerging chemicals, and trying to keep up with methods or expand our PFAS method to include more of these emerging PFASs is quite a challenge for the lab. It's a very long process to go through that method development. So sometimes what we'll do, as I mentioned Amina Salamova's lab, is we'll work with an academic or private lab that's working on a new method, we might see in one of our pilot studies what's coming up that we want to consider, and then try to incorporate that method into one of the labs. In the case of PFAS, it would be over at DTSC. But it's something we have to consider carefully, because the resources and time that go into method development are considerable. And I don't know, maybe one of the lab folks is online, wants to address that.
Go ahead, Laura.
Yeah, I had kind of a related question, which is, I was just wondering if more Nerissa, or maybe you'll be presenting on this at a future meeting about the IPPs. And like because I know there's one about PFAS, but also PAHs and VOCs. So I was just kind of curious where those are, and how they went or are going, and what maybe is planned.
So the IPP, the intra-program pilot, it's our method development. It's beyond laboratory methods. It's really just trials of different laboratory or field processes that we want to try out on sort of an internal group before we use it in a general biomonitoring study. So, for example, in the past, we looked at quacks also with an external lab to see if it was something that we would consider bringing into a biomonitoring study. The PAHs were, it was an expansion, or I guess an improvement of the method. And so, again, demonstration that the data were usable, that if we saw detection levels that we would expect to see. It's an opportunity for us to kind of do a dress rehearsal and try out the method and make sure that the data is usable or useful before we promise it to external partners. The last one, so PAHs we did run, and we're actually about to return those results to the participants. And I guess we're, as part of our consideration of 2026 topics, I mean, this might be something that comes up. We could talk about them as a body of work, or we could have a discussion about why we chose to test a new method and what the outcome of that is. And this is particularly true for something like the microsampling devices, which I think everyone's really interested in hearing about. We'll be doing an assessment of both, are there differences in capillary blood versus venal samples? How do the PFAS and metals results look between those two sampling techniques? But also, what's the acceptability among participants? Do they like having samples collected in that way? Are they more or less painful than venipuncture? So I think there will be a lot of results that come out of the next round of IPP that we'd be happy to share with you. But I think that would be a good addition to our discussion for the 2026 topics about things we would like to see.
And it's a small point. I'm Kathleen Atfield, a research scientist supervisor over at EHIB. Just to point out, of course, that these IPPs are always small. It's like less than 40 people. So we don't try to use that data as sort of understanding anything about the California population per se. It's more about method development and testing and field implementation testing.
If there are no other questions, I want to just thank Nerissa and Ian again for great presentations. And we will take a 10-minute break and return at 2:20. Thanks so much.
Thank you all for your comments.